Hello, Algebra 1. First I want to apologize. I have a bit of a cold, so I'm sounding a bit nasally and scratchy throat. But we'll still get through the lesson. It'll be great. Alright, the first thing that we would like to do is circle each ordered pair xy that is a solution set to the equation 4x minus y is less than or equal to 10. So we're just going to take each one of these ordered pairs and plug them into the equation and find out which one's true. So first of all, 3 comma 2. 3 is your x, so 3 times 4 is 12. Minus 2, is that less than or equal to 10? Yes, that is actually equal to 10. 2 comma 3. 2 times 4 is 8. Minus 3, is that less than or equal to 10? Yep. 5 is less than or equal to 10. It's actually less than. Negative 1. So negative 1 times 4 is negative 4 minus a negative 14, which is plus 14. That equals 10, which is less than or equal to 10. 0, 0. Let's see, I have 0 minus 0. Is that less than or equal to 10? Yes, it is. And last but not least, 1 and 6. 4 times 1 is 4. Minus a negative 6 is less than or equal to 10. So I've got 10 is equal to 10. All of them work. Crazy. All right, I'm going to go ahead and erase those so I have some room to work. Let's try the next set of numbers. 5 and 10. 4 times 5 is 20. Minus 10 is 10, which is less than or equal to 10. Looks like all these things work. 0, negative 10. 4 times 0 is 0. Minus a negative 20, which is positive 10, is less than or equal to 10. I don't know what I said there. 0 minus negative 10 is less than or equal to 10. That's also true. Let's try 3. 3 times 4 is 12. Minus 4 is 8. And that is also less than or equal to 10. 6 times 4 is 24. Minus 0 is not less than or equal to 10. And then 4 times 4 is 16. Minus a negative 1, which is 17. I'm not sure what I'm writing there. Which is not less than or equal to 10. All right, we got them all. Plot each solution as a point in the coordinate plane. Okay, I'm going to pause and do that. There's all the points plotted in the coordinate plane, all of the solutions that actually work. I did not plot 6, 0 or 4, negative 1. Okay, describe the location of the solutions in the coordinate plane. How would you describe the location of solutions in the coordinate plane? Well, they look to be mostly on the right. We could say that they're either like above that line, or I could draw something here and go below that one. But they're definitely clustered in some type of line some way. So this next one says, discover as many additional solutions to the inequality 4x minus y is less than or equal to 10 as possible. Organize the solutions by plotting each solution as a point in the coordinate plane. Be prepared to share the strategies you use to find these solutions. We can just plot some extra points. Give me a second. I plotted a few more points. I could keep going. I could plot an infinite number of points, but that's not really worth my time. Okay, this next step says solve the inequality for y. So I have negative y less than or equal to, I'm subtracting 4x from both sides, and then dividing everything by negative 1, which means I have to flip my inequality, remember? So I solved the inequality for y. Now, if I looked at it, I could plot this line. I have a slope of 4 and a y-intercept of negative 10. All right, the next thing in your packet, which is part D, says, complete the following sentence. If an ordered pair is a solution to 4x minus y is less than or equal to 10, then it will be located on, above, or to the left of the line y equals 4x minus 10. Explain how you arrived at your conclusion. That's not actually how I like to work these problems. I like to always find my slope-intercept form, plot the point 0, 0 as a test point, and see what happens. If I say 0 is greater than or equal to negative 10, because those are both 0, is that a true statement? Well, yes. Yes, it is. That means I'm going to shade where the 0, 0 falls. After I plot this point, plot the lines. I'm going down to negative 10. Let's see if I can get a different color here. Negative 10, and then I'm going to go up 4 over 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. I could keep going, but I think I'm good. And I want to shade where the 0, 0 is part of the solution. And there's the 0, 0. So I'm shading every single ordered pair in that shaded area is a solution to that inequality. That's what goes in your paper, on, above, or to the left. However works for you. Those are all your options. All right. The solution x plus y equals 20 is shown on the graph below. You can put that in slope-intercept form by solving for y. Graph the solution to x plus y is less than or equal to 20, and I'm still putting it in slope-intercept form. Subtract x. So I have my y-intercept, which is up at 20. This goes by tens right there. My slope of negative 1. This is a solid line because I'm less than or equal to. It would be a dashed line if I were just less than. I'm going to put in my 0, 0 test point, which I always do. Is 0 less than or equal to 20? Yes. Yes, it is. So I'm going to shade everything which has the 0, 0 as part of the solution. Here I'm going to put it in slope-intercept form again. Graph it. So I'm up at 20. Slope. This time dashed line because I'm just less than. I'm going to test my point 0, 0. Is 0 less than 20? Yes, it is. So I'm going to shade everything that includes that 0, 0. All right, let's try another one. Slope-intercept form, because that's how I roll. Subtract x from both sides. Okay, graph my 20. I graphed the y-intercept first, then I graphed the slope. And here we have a solid line because it's greater than or equal to. And then I test my point, 0, 0. Is 0 greater than or equal to 20? No, no it's not. So we do not want 0 in the shaded area as part of the solution. And the last one on this slide, slope-intercept form, just subtract x from both sides, test my point 0, 0. Is 0 greater than 20? No, no it's not. So let's plot it. Here we're doing the dashed line, and we're shading where the 0 is not in the shaded area. The 0 is not part of the solution. Very cool. All right, exercises 3 through 5. Use a separate sheet of graph paper, plot the solution sets of the following equations and inequalities. Which of the inequalities in exercises are linear inequalities? Let's do that first. I'm going to circle the linear inequalities. That is not, because I have an x squared. This is a circle. Okay? So I'm not circling them, I crossed them off. Not linear. Okay, anything that's squared, multiplied by each other, etc. Everything else is going to be linear. Cool? All right, I'm going to sketch out a few of them. These right here are all, are all somewhat related. And then these are somewhat related. Need another color. Somewhat related. All right, let's do those first three. I need to put those in slope-intercept form because that's how I work. If I subtract x from both sides, I have y is equal to negative x plus 10. So y is equal to positive x minus 10. I multiplied everything by 1. So if I sketch that out, I'm going down here to negative 10. My slope is positive 1. So my graph is going to look very similar to that. Cool? All right, now for this next one, I'm going to have negative y is less than negative x plus 10, multiply everything by negative 1, and I get y is greater than x minus 10. So it's the same line because my y-intercept is negative 10, my slope is 1, I just need to shade it. If I do that test point of 0, 0, I get 0 is greater than negative 10, which is true. So I want everything in here to be shaded. So that would be, we finished part A and part B. Ooh, except that for part B, I hope you guys are paying attention, I have a dashed line. So if I can't do a dashed line, let's see what I can do here. I'm trying to erase. Do you see my eraser marks? There we go. I need a dashed line for part B. I hope you're listening to my words. Dashed line for part B. And then part C, y is greater than x minus 10, which is the same equation. Ooh, sorry about that. All right. Okay, let's do D and E in red. My y-intercept is 0, my slope is 1. That means my line is going to look a little bit like that. Here the test point really doesn't work, but I know that y is greater than x, so I shade everything up and to the left. That's part D. Okay, part E, x is greater than y. That means that I would shade everything below. Let's do that. That's part E. Okay, rewind and listen again if you're confused. All right, I have a solid line because my inequalities are greater than or equal to. And for part D, I'm shading where y is bigger, and part E, I'm shading where x is bigger. Cool? All right, I need some more space to do the next few. Okay, now I am in purple. I'm doing F, G, and H. Y is equal to 5. 1, 2, 3, 4, 5. I'm at y equals 5 on my coordinate plane. This is 5. So y equals 5 is a horizontal line that goes through the point y equals 5. Now if we do y is less than 5, so I hope you're following along. This is part F. I'm going to change it for part G though. Y is less than 5. I need to dash my line. Now I'm working on part G. I got my line dashed, and I'm going to shade everything that is smaller then y equals 5. I can plug in 0, 0. Is 0 less than 5? Yes. Yes, it is. Cool. So that right there is part G. Now let's look at part H. X is greater than or equal to 5. 1, 2, 3, 4, 5. Need to draw my vertical line of x is equal to 5. And now if I want to shade everything greater than, this is where everything is greater than 5. Cool? All right. Let's switch to blue. I'm working on I. Here I have y is not equal to 1. So I'm actually going to make that a dashed line. Y is not equal to 1. And I'm going to shade everything else because the entire graph minus that dashed line at y equals 1 is part of the solution set. And I need some more space, so I'm going to get another page. All right, we finished all of those, that one. How about x equals 0? X equals 0. Coordinate plane. X equals 0 is right there because I got 1, 2, 3, negative 1, negative 2, negative 3. That is x equals 0. So to show you what the graph looks like, it's actually the y-axis. That is the line x equals 0. How about x is greater than 0? Oops, that's all right. So to do x is greater than 0, first I draw my line, x is equal to 0. And then I shade everything bigger on the bigger side where x is greater than 0. And then y is less than 0. First I need the line y is equal to 0, which is the x-axis. That's the line y equals 0. And then I shade everything smaller. There we go. All right. Last part of the problems. Describe in words the half plane that is the solution set to each inequality. In words. So here I've got y is greater than 0. In words, that would be the half plane lying above the x-axis and it includes the x-axis. The next one would be the half plane to the left of the line x equals negative 5, not including the line x equals negative 5. That would be that dashed line, okay? That would be a dashed line. Here I'd have the half plane above the line y equals 2x minus 5, including the line y equals 2x minus 5. And this last one would be the half plane below the line y equals 2x minus 5. So to repeat that, the half plane below the line y equals 2x minus 5, not including the line. y equals 2x minus 5. Cool? Cool.